Okay. So today we are going to start May-June 2023 paper 2. Let's start with question number 1. The melting point of some solids are shown in table 1.1. There is a magnesium, phosphorus, sodium chloride, and sulfur. So if you recall, magnesium is a metal, phosphorus is a non-metal, sodium chloride is a ionic, and sulfur is also a non-metal. The bonding over here in magnesium will be metallic bonding. In phosphorus, there will be a covalent bonding and intermolecular forces of attraction. In sodium chloride, there is going to be ionic bonding. And in sulfur, there is again covalent bonding within the molecule and intermolecular forces of attraction between the molecules. I hope you guys recall that. Is this clear? So what we are
Yes.
saying is the type of bonding present in magnesium and in sodium chloride. So as we just discussed, that the bonding in magnesium is metallic and bonding in sodium chloride is ionic. Now have a look at question number 1A. Part 2. Explain the difference in melting point of magnesium and sodium chloride. So if we see, the melting point of magnesium is 923 and the melting point in sodium is 1074. So it means that the melting point of of sodium chloride is higher than the melting point of magnesium, right? So from that we conclude that the bonds in sodium chloride are stronger than the bonds in magnesium. So we can write that
सर
bonds, yes.
मैंने उल्टा लिख दिया.
Okay. In sodium chloride is stronger. That we know that the melting point and boiling point depends upon the bonds and intermolecular forces. So if sodium chloride have a higher melting point, it means that the bonds in sodium chloride is stronger than the bonds in magnesium. Is this understandable? Yes, Abdullah, Saeed, Ahmad, and Isha.
Yes, sir.
Yes, sir, but इसमें हम bond type नहीं बताएंगे.
No, they have see in the first part they have asked you the type of bonding in both of them, and then they ask you to write the difference. And it's for 1 mark, so you have to conclude that if it have a sodium chloride have a stronger bond, that's why its melting point is higher. Is it clear now? Yes. Yes, Abdullah. Now, question number 1A, part 3. Explain the difference in the melting point of phosphorus and sulfur in terms of structure and bonding. So, if you recall that the phosphorus is a molecule of P4, which means it has four atoms, and the molecule of sulfur is S8, which means it has 8 atoms. Is it clear?
Read upon.
So,
Yes, sir.
So phosphorus is P4 and sulfur is S8. If you recall the atomic structure, atomic number of phosphorus, it's 15. So it makes 15 times 4. So the number of electrons in phosphorus will be 60 electrons in the phosphorus molecule. And in sulfur molecule, the atomic number of sulfur is 16. And there are 8. So 16 times 8 will be 128 electrons. So basically, the intermolecular forces depend upon the number of electrons present in a molecule, and the melting point depends upon intermolecular forces wherever there are intermolecular forces in the simple molecule. So we can write that it's for 2 marks, right? So we can write it in this way. In S8 molecules of sulfur, the number of electrons are more than the P4 molecules of phosphorus. Is this point is understandable to each one of you? Yes. Saeed, Abdullah, Ahmad, and Ishaq, that will secure your 1 mark. And for the second mark, we can write that intermolecular forces, we call them instantaneous or induced dipole-dipole forces or instantaneous dipole-dipole forces as well. So we can write that
सर मेरे
instantaneous
दिमाग में एक सवाल आया है
wait for a minute, and induced dipole forces in sulfur are stronger than phosphorus. Yes, is this point is clear to everyone? Yes, Saeed, Ahmad,
रीड
Abdullah.
वैसे बताएं मैं वही सवाल पूछ रहा था
Please wait for a minute. Yes, Abdullah, is this clear?
Yes, sir.
Yes, Isha?
जी सर
Okay. Yes, Ahmad, you can ask question now.
वैसे इन फोर्सेस का नाम डाइपोल डाइपोल क्यों है सिर्फ डाइपोल से क्यों नहीं हो जाता काम
Because there are, whenever we are talking about these forces are between 2 molecules, and both of the molecules have a dipole. So that's why we use it twice. We use the term twice. Okay.
सर
Yes.
सर ये जो आईडी फोर्स है इसका पता चलता है हमें इलेक्ट्रॉन्स है ना जितने इलेक्ट्रॉन्स होंगे उतने ज्यादा होगा ये
Bilkul. Yes. The more the number of electrons are in the molecule, the more stronger the induced dipole and instantaneous dipole forces of attraction will be. And if these forces of attraction will be greater and more, the melting point and the boiling point will be higher then.
ओके
Clear?
Yes, it's clear.
Okay. Now, in question number 1B, part 1, they ask you define electronegativity. So we can write it is a power of an atom to attract electrons towards itself. So you have to remember the definitions. Now they are asking, explain why the electronegativity increases across a period. For example, let me take the example of period 2 to make you understand why this is happening. In period 2, the first element is lithium with the atomic number 3, that is the number of protons in its nucleus. Then the next element is beryllium with the number 4 protons in its nucleus. Then we have boron with the 5 protons in its nucleus, then carbon with the 6 protons, and nitrogen with the 7 protons, oxygen with the 8 protons, fluorine with the 9 protons, and neon with the 10 protons. So when we move across the period, the number of protons are increasing, which means the charge in the nucleus is increasing. And as they all are in the second period, which means they all have a 2 shells in atom. So in their atom, there is going to be 2 shells. So the shells remain same. Nuclear charges increases, and as a result, there will be a stronger attraction between the valence electron and the nucleus. That's how the electronegativity increases. So we will write across the period nuclear charge increases electrons are in the same shell. For that, you can write that similar or same shielding. Both can be considered as same thing, okay? Hence, nuclear attraction for valence electrons increases, which means that the electronegativity increases. Is this point is clear to everyone? Yes, Saeed, Ahmad, Abdullah, and Isha. If any one of you have any concern, do ask. Yes, Saeed, is this clear?
Sir, down the group it decreases, right?
Yes, it is decreases because the number of shells are increasing and the shielding effect is also increasing down the group. Although there is an increase in the nuclear charge, but that the increase in the nuclear charge becomes insignificant due to the increase in the number of shells and the shielding effect. So the nuclear attraction between the valence electron or two for the valence electron would decrease, which means that electron negativity decreases. Yes, is this clear now, Saeed?
Yes, sir.
What about you, Abdullah?
Clear, sir.
Yes, Isha,
जी सर
Ahmed,
एक सवाल है,
yes,
do the valence electrons mean in the electrons in the last shell?
yes,
जैसे फॉर एग्जांपल नाइट्रोजन का है 2+5, तो फिर वैलेंस में 5 होंगे। हाँ
yes.
ठीक है, मगर वैसे
Now,
एक बात बताएं, नियॉन
yes.
एक यहाँ पे बहुत बड़ा आउटलायर है। जैसे यहाँ पे नियॉन फिर उसकी इलेक्ट्रोनेगेटिविटी तो 0 होगी आई थिंक।
How you are saying that it's outlier? Isn't it that in the nucleus of a neon there are 10 protons, which the
ये तो
number
अपनी
of
जगह है,
protons is greatest among all the period 2 elements, and it also have only 2 shells. So isn't it that the outer electrons would be attracted towards the nucleus with the greatest force?
ये तो वो अपनी जगह है। मैं मैं देख रहा हूँ कि ये दूसरे इलेक्ट्रॉन्स की बात हो रही है, अगर किसी से रिएक्शन करवाना हो, क्योंकि सारे नियॉन तो एक नोबल गैस है।
Yeah, in that case, when we talk about the reaction, it doesn't do the reaction because its octet is full, completely filled. But the attraction from towards the new valence electron would be greatest in neon among the period 2 elements. Okay.
मतलब आप ये कह रहे हैं कि अंदर का अट्रैक्शन इतना पावरफुल होगा कि वो बाहर के वो नहीं कर पाएगा।
The outermost shell is already completely filled. It had our 8 electrons in its valence shell, right?
Yes.
So how could the neon gain another electron?
नहीं, मेरा मतलब है कि उनके इसके अंदर इतने ज्यादा अट्रैक्शन है इलेक्ट्रॉन्स में ही कि उन्हें किसकी जरूरत नहीं है, मेरा ये मतलब है।
It doesn't have a space for any other electron. That's why.
Okay, I got you now.
Next, part 3 of B of question number 1. Name the strongest intermolecular force that exists between ammonia molecules. Yes, Isha, can you answer this one? Yes, Abdullah, can you?
Sir, NH3 is ammonia, so covalent.
Intermolecular force. They didn't ask the force which is within the molecule.
बल्कि उसमें से हाइड्रोजन बॉन्ड होगा।
Yes, very good. It's a hydrogen bond. Let me recall you what is hydrogen bond if you guys forget that if there is a hydrogen in one molecule and that hydrogen is covalently bonded to either fluorine or oxygen or nitrogen, and that hydrogen is attracted by any other molecule, and that fluorine or oxygen or nitrogen from any other molecule is attracting that specific hydrogen which itself covalently bonded to either fluorine or oxygen or nitrogen, then this attraction is considered as hydrogen bond. This intermolecular force of attraction is called hydrogen bond. Is this clear to everyone?
Yeah.
Okay.
Sir,
Yes, Saeed.
sir, it means that this hydrogen bonded covalently with fluorine, oxygen, or nitrogen will attract, if it attracts fluorine, oxygen, or nitrogen, then this attraction is known
of any other molecule,
Okay.
and that hydrogen bond.
So in example NH3, can you explain exactly? Clear.
Yeah, because in the next part they have asking that thing only.
Okay.
Isha, did you understand what hydrogen bond is?
Yes, sir.
Abdullah?
Yes, sir.
So here they are asking you, draw a diagram to show the formation of the strongest intermolecular force between two nitro ammonia molecules. So that strongest intermolecular force is hydrogen bond, right? Include any relevant lone pairs of electrons and dipoles. Okay, so see, if I draw one nitrogen molecule, I know that there is one nitrogen ammonia molecule. In that ammonia molecule, a nitrogen atom is bonded to a 3 hydrogen atoms, and it have a lone pair of electron. Then this nitrogen becomes partial negative because of its higher electronegativity, and these hydrogen become partial positive due to their lower electronegativity. Now what you need to do, you need to repeat the same structure in front of it like this, and then these partial charges which I put with the green are the dipoles, and then from the lone pair I will make a one dotted line towards the hydrogen of the other molecule, that this dotted line represents the hydrogen bond, and that's how you will make this diagram. Is this clear?
Clear.
Yes, sir. Yes, Said, is this clear to you now? Yes, Abdullah. Yes, Isha.
Clear, sir.
जी sir.
Now, the melting points of ice is what? H2O, and ammonia is NH3. Is shown in table 1.2, suggests two reasons for the difference in the melting point of ice and ammonia. So if you see that the ice have a higher melting point as compared to ammonia, and they ask you two reasons. So in ice, hydrogens are bonded to oxygen, which is a electronegative element, and here in ammonia, hydrogens are bonded to nitrogen, which is also an electronegative element. But if you look in the period 2, you will find that in group 15 there is a nitrogen with the atomic number 7, and in group 16 there is a oxygen with atomic number 8, right? So oxygen have a more nuclear charge, same shell as nitrogen, so it means that it is going to be more electronegative than nitrogen. That is the one thing, one reason. So you will write one reason over here, that oxygen is more electronegative than nitrogen. Now, if you see how many lone pairs one oxygen atom have, yes,
2,
and how
2,
many lone pairs one nitrogen atom have?
1.
1.
So see that the hydrogen bond is made from the dead lone pair of electron. So the second reason would be that uh, oxygen forms two dative bonds. Sorry, my bad.
यहाँ पे डेटिव एकदम कहाँ से आ गया?
Two hydrogen bonds because it have a two lone pairs, whereas nitrogen have a lone pair, so nitrogen forms one hydrogen bond. So the number of bonds between ammonia molecules, number of hydrogen bonds between ammonia molecule are lesser, and the number of hydrogen bonds between water molecules are more. That's why water have a higher melting point than ammonia. Is this point is clear to everyone? Yes, Saeed?
Yes, sir.
Yes, Isha?
Yeah.
Yes, Isha, is this clear?
जी सर.
Yes, Ahmad and Abdullah?
Yes, it's clear.
Clear, sir.
Now, in question number 2.
सर
जी सर.
Yes, Saeed?
सर ये जो मेल्टिंग पॉइंट आइस की ज्यादा है वो बस आइस में होती है फिर वाटर में भी सेम सेम चीजें होती हैं? दो रीजंस.
If we talk about water, what is the difference between ice and water?
The molecules are more apart from each other.
No.
Hmm.
Water have an anomalous behavior. When it's water, the molecules are closer as compared when they are present in ice.
Oh,
You will read that in the bonding. I have shared the notes. Okay.
okay.
यहाँ भी बता सकते हैं.
But the number of hydrogen bonds between water molecules is also the same as in ice because oxygen have a two lone pairs. So one water molecule or one oxygen atom is forming two hydrogen bonds. Okay.
Okay.
Any further question?
No, sir.
Okay. Now, question number 2. Chlorine is a reactive element. It forms many compounds. Okay. When we have to write chlorine, we will write as Cl2 unless examiner say chlorine atom, then we will write Cl. Complete table 2.1 to show the maximum oxidation number of elements from sodium to phosphorus in their chlorides. So after phosphorus, if you look at the periodic table, you will find there is a sulfur, and after there sulfur, there is a chlorine. So chlorine is most electronegative one among these, which makes chlorine partial positive or partial negative or a negative, and due to which the oxidation numbers of all these are going to be positive. So sodium will get a positive 1 oxidation number because it's in group 1. Magnesium will get a positive 2 oxidation number, aluminum will get a positive 3 oxidation number, silicon will get a +4 oxidation number, and phosphorus will give a +5 oxidation number. Is this clear?
दोनों में
Yes.
से पीरियोडिक टेबल के आम कानून के मुताबिक P तो -3 होना चाहिए.
Yes, but did you forget redox where we discuss when two non-metals are bonded, the one with a more electronegativity become negative and the other become positive.
Oh, I forgot.
So they all are going to bond with the chlorine, which is the most electronegative among these. So whatever the element, whether phosphorus or any other element from period 3 is going to bond with chlorine, as chlorine's electronegativity is higher, which makes the oxidation number of chlorine negative, and the oxidation number of the other element would be positive then. Is it clear now?
अब clear है.
Yes, Ahmad, Abdullah, Saeed, and Isha.
Clear.
जी sir.
Okay. Now question. State what determines the maximum oxidation number of elements in period 3. So if you see, it is present in group 5 or group 15, right? So it have a 5 electrons in its valence shell, and in the similar way, the silicon have a +4 oxidation number and it have a 4 electrons in its valence shell. So the reason over here is the valence electrons are the ones which determine the maximum oxidation number. So we just write the valence electrons. Is this clear?
Yeah.
Okay. Now, an excess of cold water is added to chloride of silicon. Chloride of silicon is SiCl4. Write an equation for the reaction between excess of cold water and chloride of silicon. This is the reaction that we studied in period 3 elements. The chloride of silicon is SiCl4 and it is added in water. If you see the notes, you will find the equation. We will get silicon dioxide and HCl. To balance the equation, I have to put a 4 over here and I have to put a 2 over here. Now see, the equation is all balanced.
गर्म पानी के साथ क्या रिएक्शन होता है, इसमें क्या फर्क होता है?
Same reaction will occur. Suggest the pH of a solution produces in B1. Yes, what would be the pH of this solution?
Acidic.
2 or 1.
Acidic, right? So, and HCl are forming which are strong acids, so you can write 1 or 2, okay? Now, next part. An excess of cold water is added to a chloride of phosphorus. Write an equation for this reaction. Okay, so as phosphorus have a +5 oxidation number, so its chloride is going to have a formula of ECl5. And when I add it in water, I'm going to get phosphoric acid. And HCl. So if I have to balance the equation, I have to put a 5 over here. And I have to put a 4 over here. Now, if you see, the equation is balanced. Suggest the pH of the solution produced in C1. So phosphoric acid is also considered as a strong acid. So you will write 1. Write an equation for the reaction of chlorine with water. If you recall, this reaction is a disproportionation reaction where when chlorine reacts with water, it forms the one product would be HCl and the other product would be HOCl. Now in D2, write an equation for the reaction between chlorine with hot NaOH. So if you recall chlorine with hot NaOH, we will, sorry, one product will be sodium chloride and the next product would be NaClO3 along with water. So to balance the equation, Give me a minute, please. To balance the equation, I have to put a 5 over here, 3 over here, and 5 over here. Now have a look. Okay, it is going to be 6. Is this clear now?
Okay.
Yes, sir.
Just 15 minutes. Okay. Yes, is this equation is clear to everyone? Yes, Abdullah, Isha, you guys have to review the inorganic notes where you are going to find all these equations, okay?
Okay, sir.
Okay, sir.
Okay. Now, question number 2, part E. Bleach is used as a cleaning product to kill bacteria. It is made by adding compounds like sodium chlorate 1 and NaClO. 1 is telling me that the oxidation number of chlorine is +1. Identify the formula of the ion present in bleach that kills bacteria. So let me tell you, if you split it into ions, it will form sodium ion and a ClO negative ion. So that ClO negative ion is the ion which kills the bacteria. Okay. Now, in the next part, they are asking sodium chlorate NaClO reacts with hydrogen peroxide. Its formula is H2O2 to produce sodium chloride, water, and oxygen gas. Construct an equation. Okay. So we have NaClO reacting with H2O2, giving you NaCl plus H2O plus oxygen. So see, they have mentioned you the reactants and the products both, so you have to put it in the equation wisely. And if you see, the whole equation is already balanced, so there is no need to balance this equation. Is this as clear to everyone?
Yeah.
Okay. Now have a look at this part. A sample of bleach W contains a known concentration of sodium chlorate 1. Okay, we don't know. 10 centimeter cube of W is diluted with distilled water to make a total volume of 100 centimeter cube. So we got W 10 centimeter cube, and then it is transformed into 100 centimeter cube. Now from this 100 centimeter cube, if you read the continue reading 25.0 centimeter cube, then that is the W. What we did, 25 centimeter cube of a diluted bleach solution is added to an excess of hydrogen peroxide and the volume of gas produced measured under room conditions. The experiment is repeated and an average 25 centimeter cube of dilute bleach solution produces 42 centimeter cube of gas. Calculate the concentration in gram per dm cube of sodium chlorate. Okay. So we know that 42 centimeter cube of gas is produced, and if you see, there is only one gas. So it means I can find the moles of oxygen. So if I have to find the moles of oxygen and the volume of a gas is given. So we divide that volume with 24,000 centimeter cube or 24 dm cube. I think we will get the number of moles 1.7 exponent. If you look at the equation, the mole ratio of the, and this one is going to be equal. So moles of NaClO the mole ratio is same, so the mole is going to be equal. Just a minute. Okay. Okay, there is no need of this one. These are the moles in 25 centimeter cube. So 25 centimeter cube volume into 1 point. Oh, sorry. We take 20 centimeter cube out of 100 centimeter cube, so we have to find the moles in 100 centimeter cube. So X would equal to 100 into 1.75 exponent minus 3. We have to divide it with the 25. Yes, can anybody tell me the answer, please?
Seven times 10 to the minus 3.
Yes, can you repeat the answer? 7 point
10 to the minus 3.
0 exponent minus 3. So these are the moles which we got in 100 centimeter cube of diluted solution and in 10 centimeter cube of concentrated solution. So to find the concentration of NaClO, I will use these moles divided by its volume, which is 10 centimeter cube, converted into decimeter cube. So now can anybody tell me the answer? Yes, please.
0.7.
0.7. So that is mole per dm cube. But the examiner asks you to find the grams per dm cube. So you have to find the mass. And for that, you will multiply this with the MR of NaClO. So 23 and 58.5, 58.5 and 16, 68.5. 74.5. That is the MR. So just multiply it and tell me the answer, please.
52.15.
52.15. So we will round out to 52.2 grams per decimeter cube. Yes, is this clear? Yes, Abdullah and Isha.
जी सर।
Okay, then we will be ending our class over here, and in the next class we will continue forward.